Okay, hello everyone. So by far we learned all kinds of methods for classification. So today we're gonna start a new topic. Instead of considering the classification problem, we consider the regression. Okay. Specifically, we're gonna talk about a few techniques for the regression, including least square linear regression. Least square linear regression. Also, we're gonna introduce the logistic regression. Where they say the logistic transformation in the QLD and LDA and QDA, where we fit the normal distribution first, and then we find the posterior distribution by transforming the deterministic function by the logistic transformation. But now, instead of doing that, can we directly find the best fitting logistic curve to the data? Okay, so that's different, looking the problem from different angle. Okay, so let's start the new topic, regression. So regression, basically what we are doing is we are finding the best fitting curve to the data. Well, the classification for the classification, the problem is given a data x, given a point x. We want to predict a class. A label, for example, you have the handwriting digits. You want to predict which number of the digit it is. You predict either the new patient has cancer or no cancer. So that's the classification. But the regression considers another set of problems. Given a point x, we want to predict a numerical value. Okay, so in other words, the classification gives a discrete prediction, where regression gives us the quantitative prediction, usually on a continuous scale. We have already seen an example of the regression in the Gaussian discriminant analysis, QDA. QDA and LDA not just give us a classifier, but they also give us the probability of the particular class label is correct. So you can also think about QDA and LDA is also a regression, but the response variable we want to predict is the probabilities. So to consider a regression problem, you want to consider several factors. You want to consider, you choose the form of the regression. For example, you can choose a linear function, you can choose a nonlinear function, and here with parameter w. Okay, is similar to the choosing the decision functions in the classification methods. For example, we choose a linear, quadratic, logistic decision functions in the classification problem. Once you decide the function form, second step is you find a cost function, because we want to we want the model to learn these parameters from the data, so we need to choose some cost function to optimize. Usually it's based on loss function. Okay, for example, the L2 loss, L1 loss, it measures how far from the predictions and their estimations. Okay. Okay, so now let's consider several different options can be considered for the regression, which we will give more details in the following few lectures. So what's the options for the regression function? Regression function. First choice is you can pick a linear one. For example, your function will be regression function will have the parameter weight and also the intercept alpha. So this will equals to w is a weight vector dot product with x plus alpha. Okay, so this is a linear regression. Second choice, polynomial regression, right? Polynomial regression. It's equivalent to the linear regression, but you add more features. Adding polynomial features. Okay, so that's the second options you can go with. And third one, you have the logistic regression. Logistic regression means you also have the intercept, slope intercept, but now you give the logistic transformation of the linear regression function, so you have the S, where this S is a logistic function. Remember, S is logistic function, which is given by 1 over 1 plus e to the power negative x. Okay, so that's a few choices for the regression function. We also can pick remember we already see the largest transformation in the classifications, right? Discriminant analysis, where we apply the QDA and LDA to produce the posterior probabilities functions with this transformation. So logistic function seems to be a natural choice to modeling the probabilities. If we want to model the posterior probability, sometimes we use the discriminant analysis. But here, alternatively, we can skip the fitting the normal distribution step in the QDA. We can directly using the techniques to find the best fitting logistic curves to the data. So, yeah, that's the differences between the Gaussian discriminant analysis and the logistic regression. Okay, so that's the first step. You choose a regression function. Second, you choose the option for loss function. There are also few choices. For example, we have the choice A. The most popular one is the squared loss. If you have suppose this is y is the true value, and z is predicted value. Okay, so this is equals to the differences between predicted and true. You give a square. Okay, it's called a square loss. The part B, but sometimes there are also another class of the machine learning tools. It's not based on the square loss. It's based on the absolute value loss. So you just pick z, the predicted value, with the true value y. Instead of using the square, you're using the absolute value. Okay, so it's absolute loss. There's another popular loss. It's called entropy loss, cross entropy. So z, y. Okay. So sometimes if you have the values between 0 and 1, okay, so you could also use this loss. So y, negative y, natural log z, okay, minus 1 minus y, natural log 1 minus z. Okay, this is called logistic loss. In some scenario, it's also called cross entropy loss. But in this loss, it requires z is between 0 and 1, because you take the log transformation, log 0 will be negative infinity. Also, the y needs to be 0 to 1, 2. Okay, so that's a few choices for the loss function. And then now you go over each data point for the loss, apply this loss functions to each data point, you get a cost function to minimize. Okay. Actually, there are also few choices for the cost function. To minimize. So the first choice for the cost function is which equals to you take the average of the loss function. So you take the you apply this loss function to every data point in your sample, and you apply the regression function to get the predicted value, and you compare with the observed yi. Okay, this is called mean loss. For example, you have the MSE. It's a mean squared error loss. And the MAE, mean absolute value loss. So that's the first choice. The second choice for the cost function could be instead considering the average one, you consider the maximum one. Okay, this is called a maximum loss. The third choice for the cost function is the weighted sum. Oh, maybe I can say one more words about this maximum loss. You want to pay attention, be careful about outliers. Because here it only considers the maximum one. So if your data is not clean enough and not well prepared data, so this maximum loss could make your model perform very bad. And the third one is the weighted sum loss. So for every data point, we give a weight. Here I just use omega I, and then you apply the loss. So this is the weighted sum loss. So there is another two types of loss cost function, which is not only you consider the loss on every data point, but at the same time you also want to give some restrictions on the parameters. You give some regularization. So if you apply any one ABC loss cost function, you plus a penalty for the large parameter values. This is W. W is a parameter in the regression function. Okay, you give the penalty. So this gives the R2 penalized cost function. In some context, it also says it's L2 regularized. Function. Similarly, we can also consider the L1 penalized cost function. It's also A, B, C plus penalty with the L1. Okay. So it's called L1 penalized. Function. So instead of considering the square term here, we consider the absolute value penalty. Okay. So that's the choices for the regression function, the loss function, and cost function. And the different combinations give us different regression models. For example, this will give us the lasso ridge regression, and this give us a lasso regression, right? So by combining the above choices, we can have the some famous regression models. Okay, maybe the first one is the least square linear regression. Linear regression. Okay, so it's a combination of you choose the function, linear function one, you give the square loss function, and you take the average loss as a cost. Okay, so this is the weighted. This is least square. This is a regular regression problem, and the second one we also have the weighted least square linear regression. So we have the linear function form. We give the square loss, but now we give the weighted loss. So this gives us a weighted linear regression. Also, we can have the ridge regression. Ridge regression is given by you still pick the linear function form plus the squared error loss, but instead of considering the regular mean squared error loss, you consider the penalized loss, so which is D. Okay, so you or maybe I should say with the square, you still have the square loss, but you add additional penalty. Okay, so this is called ridge regression, and we also have lasso regression. So lasso regression is you consider the function form, you consider the error loss, square error loss, plus the you still consider the mean squared error loss, but you give the penalty. Penalty you choose the L1 penalty, so E. So this gives the lasso regression. Also, we have the logistic regression. Logistic regression is you consider logistic regression form. So you consider logistic regression form plus the logistic loss, which is C. And then you plus the average loss. Okay, so this gives us logistic regression. And also we have the least absolute deviation. Okay, so it's you have the linear function plus plus the mean squared absolute value loss plus average loss. This is called the least absolute deviation. There is another type of the regression is also called Chebyshev criterion. Okay, it's a linear form plus the absolute value loss plus the weighted cost function. Okay, and it depends on what kind of combination regression function form you use. We can then apply some numerical methods or to minimize the cost function to get the parameter values. And for the first three, we have the quadratic loss. Cost. Okay, quadratic cost we can minimize. We have the closed form solution. Which means we can solve the minimizer by best parameter by using calculus. Okay. But the lasso regression, we don't have the closed form formulas. We need to solve it by using quadratic program. To solve the parameters. And for the logistic regression, this gives us a convex cost function. So we're gonna use some sort of the gradient descent algorithm. Descent. And the last two problem also doesn't have the closed form solution, need to solve by the linear programming. With some constraints, sort of constraints. In the previous lectures, we already give you some taste of the regression function actually, and by giving you the different loss function, different choices of the objective functions, and we solve the model parameters using different optimization algorithms. Yeah, like the perception theorem, we use gradient descent algorithms, right? And for the QDAs, quadratic discriminant analysis, we use the quadratic programs to solve the linear decision to solve the decision boundaries. Okay, so that's the brief introductions about what we're gonna talk in the next few lectures.